Welcome back to Tech Life and Fun channel's part 3 video of KillerShell Solutions 2024. Please do hit like and subscribe. That gives us motivation to make more good content like this. All right, question number 13 talks about creating two network policies and pretty straightforward stuff. The first policy says that egress to the metadata IP should be blocked, well, everything should be allowed. And the second one says that for pods with this particular role, it should be able to access this metadata host IP. So let's get cracking. Let's get the YAML for network policy. Let's copy the YAML. Let's remove the namespace and let's give the correct name. Actually, let's first create the metadata allow. Because we can just use this pod selector section. So this one is for this particular labels of pod. We only need ingress. Let's remove the port section. And the CIDR has to be this particular IP /32 for one specific IP. Let's come back. Before creating it, let's switch to the namespace. We have done something wrong here. I think we have not switched to the right context. That can be a big mistake if we do that in the real exam. Then let's go back. All right, yeah, policy created. Let's create another one. Let's call it U130. This one will be called metadata deny. And this one will be to all pods except for this one. So this goes like this. All IPs would be 0.0.0.0/0 except this one particular one. All right, we are done with this question, and let's move to next one. And talks about moving to this context and this namespace. All right, it says that few pods in this namespace are generating kill syscalls. We need to identify those pods and scale the deployments down to 0 replicas. Let's take a quick look. Yeah, we have 3 deployments and we have 3 pods. not 3 pods, but 5 belonging to those 3 deployments. So to check the syscalls, we need to run strace command on the worker nodes where those pods are running. So what we can do is we can check the node as well on which these pods are running. And yes, minus or white gives this option, and everything is running in cluster node 1. So let's SSH into cluster node 1. All right, now you have the pod name in front of you. 2 collector 1 pod. So let's take the first one and run cricktl pods minus minus name equal to. So you have got the pod ID now. So now you run cricktl ps minus minus pod, and then you give the pod ID. This gives you container ID. So next you do is cricktl inspect with a grep on args and 1 line below it. So yeah, this is the process name that this particular pod is running. So let's just see ps aux grep process name. So we see 2 processes running, and 2 would explain why that there are 2 pods against this deployment. So yeah, that's why we see 2 processes. Let's just pick up any one, and this is our final command: strace minus p process ID, and then you follow it, and then you collate it for some time minus cw. Yep, we see kill. So the very first pod is something we need to remove. We need to downgrade this collector 1. And if you follow the same process, you will find that pod 2, deployment 2 is running processes with the name of collector 2 process. And likewise, the third one is running collector 3 process. So let's just check for those as well. Collector 2 process, this is the process ID. So I'll run strace minus p. Control C. Okay, there's no kill command here. Let's check the last one. Control C. Again, no kill command. So we just need to downsize this first deployment. So let's do that. You can actually come out of the worker node and do it on the main terminal. Kubernetes kill deploy minus minus replicas equal to 0. There you go. All good. We are done with this question, and then next move to question number 15. So let's switch to the namespace in question, team pink. All right, it talks about that there's already an ingress with 2 paths in this namespace, and we need to create a TLS certificate, a secret of type TLS for the given key and certificates, and then use that configure that secret, TLS secret in our ingress. So let's see the ingress, whether it's running in this namespace. Indeed it is. So let's create the secret. Type is TLS and the name of the secret is not mentioned in the question. So you can give any name. So let's say mysec minus minus cert equal to minus minus key equal to. So cert would be this CRT, and then minus minus key would be dot key. All right, mysec created. Now to update the ingress, let's first head over to the documentation. Click on the TLS section on the right side. If you go down, so this is what you need to give under the spec section. So let's do that. Name of the ingress is secure. Secret name we created was mysec, and host we can just update to this value. We have done something wrong here. So, oh, we pasted this thing in wrong area. Maybe let's just copy it from here. This should come out of rules, not inside rules. Let's just do out of it and then edit again. So this needs to come here before the rules. Cool, it's done. And if you want, you can perform a curl on HTTPS and then see the secrets. You will, if you analyze these logs, you will find that it is your particular certificate that is being used. If you open the this particular certificate that is given to you, you will find that CN is this. So all good here. Let's move to question number 16. Let's switch to the context. Let's switch to the namespace in question. Okay, it says that there's a deployment called image verify. Yes, indeed. And it is using this V1 version of the image. We are given a Docker file which we need to fix certain things and then create a V2 version, build it using Podman, and then use it in the existing deployment. So let's head over to the Docker file. Okay, first thing is the base image needs to be a more latest one, 3.12. Do not install curl, so we'll remove curl from here. And then Nginx version needs to be changed as well, greater than equal to this value. And then the last part is run the process as my user. So user is created here, not to run it as root. This is my user. Cool. Now we need to run this podman command. Maybe let's copy it and put it in more readable manner. All right, let's build the image. If you want, you can test by running a container with this image. I'll just skip and go to the third part where we push the image to our repository. There seems to be some error. Yes, we have made some mistake in the Docker file. Let's see that. All right. We have not removed equal to here. So let's do that. Let's build the image and hopefully this time it will be a success. And in the meantime, let's copy the command for the next operation. All right, done. Let's update the deployment. And make this V2. All good here. Let's move to the next question. This one is around audit policy. So that audit policy is kept at this location on control plane node. And we need to change the audit policy to accommodate secret at metadata level and then user group at request response level. And then they say after we have done the changes, we need to truncate the previously generated log file. So audit policy and everything is already loaded on the API server, no change there. There is just one change asked of from us, like change the configuration so that only one backup of the log is stored. So we'll make all these changes and then perform this change so that API server picks up the new updated YAML as well on when it's getting restarted. So let's move inside the control plane node. Let's open the audit policy. Yeah, not much here. So for auditing, we need to open the documentation. Yep. So we have the documentation in front of us. We need one for secrets. So we have secrets down there. So let's just copy and secrets at metadata level. Metadata is already there. So we'll just leverage that. Resources secret. Yep. We are done with the first policy. And the second one is around user group. So you will find an example of user group here as well. Yeah, this is the user group. So let's just copy this thing. The level for this rule is request response, and user group would be system nodes. All right, our policy is updated. We need to update the Cube API server. We can see that audit policy and file everything is already loaded. We just need to change the max backup to 1 as per given in the question, and this will also make our API server pick up the latest changes. In the meanwhile, while the API server restarts, let's truncate the logs so that we only get the new logs. You can check the health of API server running this command. Watch -a. Let's wait for this thing to get refreshed. There you go, it's running. So we come out. We're done with this question as well. Let's move forward. All right. It says that namespace security has 5 secrets, which are supposed to be highly confidential. But there's one service account, p.oster, which has accessed some of these secrets. So we need to find out those secrets from the audit logs and then change those secrets to any new value. So let's do that. Let's switch to the namespace. Okay, so we have 5 secrets showing up in this namespace, and we need to zero down which were accessed by this particular service account. So let's try to dig deeper into the audit logs. Let's try whatever grep we can put on. We have grep on this, and then grep on namespaces given security. So let's do that, and then let's grep on secrets, and then let's see how many we have filtered. We still have 24. So maybe if we look at these in detail, try to zero down further. So for example, this is like a kind of a security breach accessing the secret. So we look at kindness event, resources secrets. Maybe let's just filter on this value. Hmm, let's look at the okay. So let's add another filter of data. Okay, we have filtered down further. Actually, this verb can also help us filter down further. So let's probably filter down on this verb get. We can add grep self-link as well, and then grep get. How many are these? 6. Great. So let's just see the name. So here you can see the names. And if you are having difficulties, what you can do is you can put all of this in a file, Q18, and then VIQ18, and then search name. That's not very helpful. So let's remove the last filter. Since we are not able to filter down any further, what you can do right now is you have some very much filtered output. Let's search for the secrets inside this file. So what we can do is cat q18 pipe grep minus e. Let's see which of these names appear. There you go. So vault token and MySQL admin are the secrets that are compromised. So let's update the value. Let's give any base 64 value uh, in those secrets. Let's base 64 encoded. We have this value PMV3. So what we'll do is secret vault token. And update the password value here. And likewise do it for MySQL admin as well. All good here. Let's move forward. Let's switch to the namespace in question. So this talks about there is a deployment created from this particular YAML, and we need to make it immutable. And we also need to mount /tmp directory. And finally, the final YAML should be present in a different location. We don't have to update the existing file. So let's just create a copy of this file into the new location and then edit everything here. So here, let's make it immutable first. And the way to do it is to add a security context. Read only, read file system true and privilege false. And then let's mount volume as well. Let's give it any name, emp, type empty directory, and then let's mount it as a volume mount. So deployment already exists. Okay, no deployment exists. So we can just simply create it from the new one. We have done some syntax mistakes. So let's take a look at it's volumes, not volume. So all right, deployment already exists. Looks like we are running it on the wrong namespace. Namespace is team turtle. Yep, there you go. So deployment is there. Let's update it. So we can do replace -f and this new file. Yes, the pods are getting updated. New one is running, old one is getting terminated. We are good. Done with question number 19. We will take a pause here and we'll see you in the next video.